right, now let's see if we can share the file. And, well, actually, we're not going to do that yet. Yeah, let's do it. Okay, let's open this as my desktop. Okay, should be good. Holy moly. Actually, I had a worse start for section 1 because they re-imaged the station here, so all my savings, nothing worked. Had to start as if I'd never seen this computer before. No warning. All right, so let's begin. This is our first worksheet, and I'm going to try to warn you about this several times. I can kind of see where people might have been misled on this. Okay, specifically, cost of capital with all equity financing. All right. What's that about? Oh, let's get the chat going and see what's going on here. Oh, it must be a recording. Okay. All right. Yeah. Cost of capital with all equity financing. That's RU. And we will never use this in the WACC equation. Right? We use RE. Okay, so the first thing to find this WACC, we have to find RE. And the way we do it, we use the equation equals RU, and we know RU is 11% plus RU minus RD times the debt to equity ratio. So we know we're 40% debt and we are 60% equity. I get 13%. Okay, now we drop that into the WACC equation because we now have RE. So we're going to say that it's 40% debt times the cost of debt, little 8%. You know, every one of these is 8%, even in the book. Oh, I had 17%. Okay, never mind. Oh, that's algebra. Times 1 minus the tax rate plus 60% times the cost of equity. Now, I think you'd be safe on an exam doing it this way, but if you're using Excel, you never want to type a number in, right? You want to point to the cell. If you start working with large numbers, it'll show the difference. Okay, anyway, there you go, 13 points. This one came out okay. So I discount these 4 cash flows, and it was kind of interesting. I was helping someone during my office, more than one, several people in my office hour, and they were not getting this number right. And I looked, and they had this right, they had this right. Every one of them had all these numbers right. Why did this not work? So I finally took the time to look at the equation here, and this group of people discounted just the first 3. Why'd they do that? Because we discounted 3 in class. I have another example like this that I sometimes use as an assignment that has 10 cash flows. You're going to discount just the first 3? No, you got to get them all, don't you? So yeah, so I'm going to discount all of these at the cost of the WACC. Okay, and once I have the value, I'll take 40% of that as the debt. And then you can do either 60% or just subtract the debt from the value to get the equity. So what does this equity mean? This is the market value of the project, correct? This is the market value of the debt that's financing the project. This is the market value of the equity that's financing this project. Okay, now I highlighted these in yellow for a particular reason, and that was to say that no matter what the problem you're working, these are always blank. We don't calculate anything for year 0 except these 3 numbers. Okay, and then we go to our first year, and we revalue the company, which is the present value of, oops, sorry, I'm in the debt column, which is the present value of the remaining cash flows. So there you go. And so on. We follow this pattern. And then the debt. Okay, now let's take a cell off to the side here if we could. I just did that to show somebody something. Let's take a, okay, and here I'm going to say equals debt to value. Let's make percent on that. Okay, if I check that each of the years here, I can't do it the last one because the value is 0. I'll have division by 0. Okay, so what was the premise when we started this problem? That the company maintains a constant debt to value ratio. So why do we have this change in debt? Because to maintain this 40%, we had to reduce the debt from 2851 down to 2745, didn't we? That's why we have this change in debt. That keeps it at 40%. That's the premise we're working under here, that we're rebalancing to maintain a constant debt to value. Okay, so we have the change in debt, the interest. You know, just think diagonal, beginning of the year debt. So we borrowed this much initially, and we'll pay interest on that number, not this number, this one. Okay. And anytime, anywhere, anytime you have interest, you have a tax shield equal to the interest, whatever it is, times the tax rate. So I just take the interest times the tax rate. Now, float equity. Remember my poor equity shareholder on my drawing? That's the carp at the bottom of the lake. Okay, so floating at the top of the lake right now is $1,000 cash flow. How much of that makes it all the way to the bottom? First of all, you have to repay your principal. You have to pay interest. But since interest is paid on an after-tax basis, you get a tax shield. So it's this one minus the change in debt minus the interest plus the interest tax shield. And that's what part of this 1,000 flows to the equity shareholder. Okay. And I populate the entire table, just fill it all up. Okay. And let's do some methods. So first one, let's do the NPV. Okay, what's this value here? That's the present value of all the future cash flows discounted at the WACC. Okay. So if I just simply subtract the cost, I get the NPV, don't I? So sometimes I don't even do this because, you know, when you got a nice 000 number as the cost, you can do it in your head, can't you? I can just see this is 112,820, can I? Well, let's do it. So there it is. All right, then let's do the APV. All right, what if we funded this entire project with just equity? The shareholders put up the entire thing, 100% equity. This would be the NPV. So we'll, oops, sorry. That's our base case NPV. So we'll discount the cash flows at the cost of debt, the cost of capital with all equity financing, 11%, and then subtract the cost, we get this. So if this were financed all equity, we would do it, wouldn't we? It's a very positive NPV. Then we take the benefit of this debt financing, and that would be the tax shields. Okay. And now how do you know whether to use RU or RD? That's the most confusing thing in this entire chapter. And what I try to show again, I'll do it again here. You see these tax shields? What happens if this last cash flow were 1,000 instead of 2,200? Watch what happens. Okay, so these are 47. Well, you just watch these. They're all different, aren't they? So this column is actually tracking this column, isn't it? Okay. So whatever is the right discount rate based on the volatility of this column would be the right discount rate for an equally volatile column here. So this is all RU, isn't it? RU and RU. All right. So we'll discount the tax shields at RU. Cost of capital with all equity financing. We add that to the base case and we get the APV. Now another thing to remember is if you are calculating APV, float equity, and NPV, they should all be the same. Okay, so let's go back up here. We had a project that cost $6,000 and we borrowed against it. The treasurer of the company borrows against it 2,851, meaning that the shareholder has to put up the difference, 3,148. So these are the flows to equity. Discounting these at the cost of equity, not RU, the cost of equity, 13%. And notice, if you do this right, this number and this number are the same, aren't they? If you do it correctly. Okay, then we take out the equity investment. Uh-oh. Is that me? What happened? Oh, someone started recording. Okay, I hope that's all it was. And we subtract the equity investment, and that's what leaves us with the NPV, the float equity. All right, now what I hope you see here, one of the takeaways is let's go back to chapter 5. We just did an NPV. And we got a number of 112820. To whom does that NPV belong? It goes to whom? Do you distribute it among the shareholders, the creditors, the suppliers? Do you distribute that among all these other people? No. Look what we just did here. The entirety of this NPV goes to the shareholders, doesn't it? That's why the company always seeks to find positive NPV investments, because that positive NPV goes directly to the shareholder. All right, let's go then to the perpetuity. So let's see, any last questions on this one? All right. Oh, can you show the equation for FTE? We sure can. Do you want the NPV of FTE maybe? Or the FTE? Nope, just the FTE. All right. It's just the present value of the cash flows to equity minus the equity investment. So it's just, you can't hardly see it, that's the trouble. So it's basically this present value minus the equity investment. Is that what we're asking? I hope I'm answering the right question. Oops. Cell I13. Well, let's look at cell I13 then. I can do that. Here's I. Oh, here. Okay. The float equity itself. Okay, I'm awake. Thank you. Okay, let's do this one all over again. Never seen it before. It equals the cash flow minus the debt that must be repaid minus the interest, and then plus the interest tax shield. Okay. Now, why couldn't I do this? Can I go equals 1,000 minus the debt minus, now I keep saying interest is paid after tax. So what if I said 47, oh, sorry. What if I said 22810 times 1 minus 21%, oh, come on, times 1 minus 21%. Can I do that? Absolutely. I get to say, well, within rounding, I'll get the exact same number. And there's our 7. Okay, so why don't I do it that way? If I were just calculating float equity, that's exactly what I would do. But I need these tax shields for APV, don't I? So that's why we separated this into 2 numbers. Does that make sense? So that's why we broke this down. We have these 2 instead of just this one after tax. We have both of these. So I need this for the APV. All right, how are we doing here? Let me look. Okay, looks like we got it. All right, let's move on then. Let's go to, what if we had a perpetuity? And I didn't even realize it, but I used all these same values up here. So you didn't have to, or these values up here are all the same. So you didn't have to recalculate anything here. Just use the same numbers that we used in the previous sheet. All right, and start out. This is an infinite cash flow. So year 1, 700, year 2, 700, forever. And the way you discount an infinite series of cash flows equals cash flow divided by R minus G. G is 0. So constant cash flows, not constantly growing, constant cash flows. So I'm going to say equals 700. And we'll divide it by, and we'll get pretty close here, 10.33. We're going to be a little bit off, but not much. And that's the value. Now you see, why is it off? Well, that's because this is actually 328, isn't it? Now we get the same thing, don't we? So see, a little bit of rounding will do to you. So again, obviously, your best bet is never to type, just go get the number. Then you'll never be wrong. Okay, and we're going to take 40% of that as debt. So let's just kind of stay together here. So I'll take 40% of that, and that I don't need to point because it's a pretty round number. And then the difference is equity. Okay, what's the parallel between this number and what we did on this sheet? Okay, this number, if we had finite cash flows, finite, a set number of them, would be equivalent to this number, wouldn't it? That's what you see here. It's the market value of the equity. Okay, so this is the market value of the equity. So do we know if we should go through with this investment yet? No, we don't, because is the market value of the equity more than the book value, more than they had to invest in this? So we follow the procedure, we get the interest. We're going to say it equals the debt times the interest rate. And then the tax shield is always the debt, is the interest, sorry, times the tax rate. And then finally, the float equity. Here we go. We have a $700 cash flow. Okay. Payback, first of all, the debt. What debt do we retire? You don't. This is perpetual debt. So this debt is the same forever. So no debt retired. So minus the interest plus the interest tax shield. And that's where we get this number. All right. And then, so this is what flows to equity. What's the present value of the float equity? Here's our equity investment. So let's do the present value of this float equity. So PV Just a point, do I already know this number? This is probably why I didn't do it, because I already know this number. But we'll do it again. I will do it a different way. I can take the float equity and divide it by RE. And RE was 13%. And that's where I got this number. I already knew that. Anyway, so let's take out the equity investment. So the shareholder has to make up the difference between the cost of the investment and the amount borrowed against it. So it's going to cost $6,000. We'll borrow against it 2,711. Shareholder will put it. Oh, look at that. Let's see, what can I do here? Okay, so the shareholder will fund 3288. This is the market value. This is basically the book value. The difference, what does the shareholder gain from this? Why am I doing that? Just do an auto sum. And there it is. That's my 77769. And then we have the base case. Base case equal to the cash flow divided by the float equity, the cost of capital, 11%. So this one you got to be careful of. It's not going to be a round number. So that's the, and then minus the cost. Okay, and that's where we get that. Then the tax shields. We have the tax shield above. And then we divide that by what? This is one of those cases. What do we do? What am I doing here? We're working with the assumption that we're rebalancing. So we're going to divide it by RU. Okay. And then therefore the APV is the sum of the two. Okay. The NPV be the value minus the cost. So they're all the same. Gotta be. They're algebraically identical. You have to do a little bit of massaging your algebra to make it work, but they're the same. Okay, so what do we have? Any questions on this one? NPV, I type that? Oh, that's me. Okay. Let's stop. All right, looks like we got the last part. Looks like I've gone all caps again. Oh, no, who knows? All right, looks like we're okay. I'm going to move on. All right. Changing capital structure. Let's go to that one. Okay, here's our balance sheet. And you'll notice the blasphemy in the top line. Book. So don't fall in love with this thing. Just take one number and run away from it. It's toxic except for this number. That's the only number we take from this. Only number. Just that one. Okay, so what do we have over here? We have the debt right off here. Okay, what if I have to explain this to somebody? Aren't I supposed to be using market values? Why am I using market value for the debt? Okay, we're using the book value as an estimate of the market value, aren't we? We're not repricing the debt. We're kind of saving a step here. All right, then equity. How do we get that? Well, we had $40 a share, and we had 400 shares. That's always, whatever you find the market value of the equity, shares times number of shares. Right, number of shares times cost per share, sorry.
Isn't that the same as market cap of like a stock?
Yes, exactly. Yeah. Interesting question. If you were on if you go to finance.yahoo.com and I bring up IBM or someone like that, and in one of the information sheets they provide, it'll say there market cap. And you can verify that by taking the number of shares times the price per share. So that changes every day, right? So the changes every time we get a new price on the stock, right? Okay. All right, so now let's do a WACC. And we use the beginning values. Our first one, we're going to say equals 20% debt, and it's 6% debt. All right, I found a way to confuse people, and I didn't mean to. I said when I was doing my office hours, I would say the interest rate on debt. Well, you notice all these things that were given, nothing there says the interest rate on debt. It'll say the cost of debt. But what is the cost of debt? It's the interest, isn't it? So the interest rate on debt is the same as the cost of debt. We can't let these words get in the way. So times the cost of debt, RD, interest rate on debt, 6%, times the tax rate, 1 minus 21%, 1 minus T, plus 80% times the cost of equity. Now, do we get a cost of equity? I think we're given that in this problem. I think it's 20. Oh, here it is. RE old. That means RE old. So we're given it as 12%. It says cost of equity. Okay. And one more time, that would not be RU unless the company had no debt. So this is the cost of equity with $4,000 of debt. Okay. So we'll put in 12% here. And we get 1054, or 55, I guess, as the WACC. Okay, now we're going to change. We are going to issue $2,000 of debt and buy back $2,000 worth of stock. We're going to do a stock buyback by borrowing money. Okay. So this company must be terribly convinced that their stock is worth more than it's selling for. They want to buy it back. So it's a bargain according to them. They'll even borrow to do it. All right. So let's, first of all, let's get our RU. Okay, and RU is exactly the WACC equation. Let's do it that way. I'm going to copy this. And plug it in here. Now this obviously is not RU, but what do I need to change? Just take out the 1 minus T. I don't think I've ever done that for you before. I've said it, it's what it is. But it's the same as the WACC without the 1 minus T. So it's RD, I'm sorry, it's weight, debt to value, RE, equity to value, RE. So debt to value, RD, equity to value, RE. So that's, now what's this? What's words for this? Cost of capital, capital with all equity financing. We just found it, didn't we? So with $4,000 of debt, the cost of equity was 12%. With no debt, that would drop to 10.8, wouldn't it? Okay, so let's continue. Let's do our new RE. Okay, and this is after the buyback. Okay, so let's start it. We're going to say equals RU. And I think this is close enough that I can type it in. Let me just see. Yeah, we're good. So equals RU plus RU minus. Now you want the new RD, not the old one. because they're going to be borrowing more money, the cost of debt can likely go up. So let's try it. 6.8% is the new RD. Now, if I give you a problem on an exam and I don't give you a new RD, just use the old one, right? Okay, times, and let's just structure this. Okay, we need debt, so debt was 4,000, and we're gonna add 2,000 to that.
What's the 6.8?
That's the new cost of debt. So when they issue this new debt, it's gonna cost 6.8. Because I mean, the debt they already have could have been issued 15 years ago. So you have to use the most recent cost. And that's kind of an oversimplification in most of the problems we do, but it stays the same, but that's all right. Okay, and then what do we do to the equity? It was 16,000. We're going to buy back $2,000 worth of shares. You see what we did? Added 2 to the debt, took out 2 from the equity, correct? All right, and there's my new RE. So it's 12.51%. And then we get our, finally we'll do our WACC. Okay, and here we go, all new values, everything new. So it will be the 6,000 of debt. Oh gosh, we have an equal sign. 6,000 of debt. Okay, divided by, now we didn't change the total value, right? It's now 6 plus 14 instead of 4 plus 16. So the bottom is still, the denominator is still the same. 20,000 times that new cost. Times, always 1 minus t. I've never yet had a problem in my life where the tax rate changed. So some fool could do that. Plus the equity. And so the equity is now down to 14,000 of the 20,000. Now, one of my pet peeves on the exams is that some people, when they rewrite this, keep in mind that if I add these 2 numerators together, they have to equal the denominator, don't they? But I'll have people that will calculate this using numbers such that these don't total to the value. They have to go. So what they'll do sometimes is take one off the balance sheet and one off, I don't know what they do. I'm just speculating, but as long as you just stay with only the debt on that balance sheet, don't take anything else from it. Okay, times our new cost of equity. So this won't be exactly right, but it's going to be pretty flaming close. And so we get a new WACC. How close did we come? That's pretty good, I think. Yeah, that's what I got when I just pointed. Okay, so this is a 3-step procedure, right? This was step 1. Okay, and then this was step 2. This is step 3. So anytime you get a problem where they're changing the capital structure or financing differently than according to their capital structure, you have to do this. All right. How are we doing here? Oh, man. Questions? All right, seeing none, we will continue. Let's move then to APV, no rebalancing. Okay, I'll just take these out. All right. So we have a cost, we have cash flows, and we're simply borrowing $3,000 against the project. Okay, nowhere here. In fact, let's go back up. Look at this. I won't always tell you this. Value the following project if the company does not rebalance. Okay, that's one sign. If I just flat say the company does not rebalance, the other way is that if you just simply see an amount of debt given, you haven't valued it, have you? How can it be 40 or 50 or 30 or whatever it is percent of debt of value? If you just see a debt given, so problem 16, your text is this way. They just tell you they're going to borrow this much. If you go directly and tell you this is how much we're going to borrow, then this is APB only. Okay, so we're going to pay it back 1,000 each year, and so this goes to 0, and this one also would be 0, wouldn't it? No debt left to be repaid. All right, so let's do our interest. So we'll take our debt times our cost of debt. What are we doing here? Oh, shock, 8%. All right, and it'll do the tax shield. All right, and then we'll just copy these down. Oh, a little further I need to go, wouldn't it? All right, let's get rid of the surplus. There we go. All right, so APB only, no NPV. No NPV, just base case. And well, there is one, but it's the base case NPV. So equals, I'm not gonna do it all by hand. Equals minus 6,000 plus the NPV of, or at RU, cost of capital, all equity financing, 11%. And then we'll take the cash flows 1 through N. And that should give it to us. All right, so what is this one more time? Would you fund this project if it were all equity financed? Yes. Okay, but it's worth more than this though, because we are using debt financing. We have these tax shields adding value. So let's discount the tax shields at RE. And RE, oh, what do I even have to look? 8%. It'd be just these tax shields, right? What difference does it make if I highlight that one or if I don't? Make any difference? No. Not a stitch. Exactly right. Because why? We're not bringing these numbers forward, we're bringing them back up, aren't we? So it doesn't make a bit. Zeros don't do anything. All right, and then if we add these together, we have the APV. All right. So no rebalancing, a fixed debt amount that we'll pay back each year in some pattern of paying back. Now I could say 2,000 here, 500, 400 or something like that, right? It doesn't have to be any amount. APV does not matter how you pay back your debt. You just have to pay it back. I mean, but okay. Life is good, I hope. Let's do the perpetuity with, here it is. I stated specifically, the company does not rebalance. Okay, and this is the same as problem number 17A, exactly, just different numbers. Okay, so let's do our base case. All right, let's do these all over again. Our base case, that would be the cash flow. Hang on a minute, I'm going to blow this up. The base case equals 700. And I'm going to take a real leaner here and say that I think it's 8%. Oh, that's not right. Cost of capital of all equity financing, 11%. Okay, we got that. Okay. All right, and then interest tax shields. All right, let's go into high gear if we could. You know, rather than interest, tax shield, let's just do it all at once. So I'm going to say equals. First of all, we need the interest. So we have borrowed what, 2,500? Perpetual debt stays the same every year. What's the interest rate? This is where I'm gonna gamble at it. It's still 8, okay, so there you go. 8%. So what's that? Now I have interest. What do I want? I want interest tax shield. So times 21%. And now what do I have? I have interest tax shield. I want the present value of the interest tax shield. Now here's something I hope you'll notice. I'll divide this by, and we're discounting this perpetual stream of cash flows at what rate? 8%. This is the RD version of it, isn't it? Okay, now what do you see here? You see that this 8% in the denominator equals this 8% in the numerator. Yeah, maybe many of you saw that. So if I wanted to, I can just take the debt, which would be 2,500, and multiply it by the tax rate. Oops. So if you have perpetual debt and you're not rebalancing, the tax shields are just debt times T, aren't they?
For your base case, MPV, don't you need to?
Oh, subtract? Probably do. That would be not a bad idea. Oh, I don't complete that. Yeah, you're right. This thing all of a sudden jumped in value tremendously. Now look at this. This is kind of an interesting one because the what? It's an acceptable project. It's an acceptable project without debt financing, but most of the value is because of the debt financing, isn't it? So we add these together and we get the APV. All right, let's go back to Neverland for a minute. See what we're doing here. All right. Got a thumbs up. All right, I'm going to say that's good enough. All right, let's move along. Okay, so now we have the problems. All right, let me blow this up. All right. So in problem, now let me share, I think this is one of our sources of confusion. In problem 14, it says on here, the expected rate of return on the company's shares is 15%. Okay, what is that? It's either RD, RU, or RE. Which is it? Okay, your company's shares. Shares go to the shareholders, right? That's RE. Okay, how do I know it's not RU? Because I have their balance sheet right down below here, don't I? And it says $208,600,000 of debt. So that's not an all equity company, is it? Therefore, that's the cost of levered equity. That's not RU. Okay, so it's a little bit differently worded, but hopefully it's not a problem. I'm not sure what this ever was. It must have been doodling. All right, anyway, yikes, I think I need it. I have no idea what that is. Anyway, let's just work this problem. So we have, and I did these in thousands, all right, rather than writing out all those zeros. So I said 7.46 million shares times 46. So these are, I'm sorry, I did them in millions. So these are millions, these are millions. And this is the, oh, I'm on the wrong sheet. No wonder I can't figure out what I'm doing. Okay, here we go. All right. See, I have two versions of this problem. What do you think they are? One is with short-term debt. One is without. What did I tell you to do? Without. So that's why we don't want to do that. Okay, so here we go. So this is the market value of the shares. This is the long-term debt. This is the total capital. So we should have done, and we can work it out. So we're going to say 3 equals 208.6, and we won't be far off, times the cost of debt, 8%, times 1 minus t, plus, oh, that's real good, debt divided by value. There we go. Plus the equity divided by value. Times the cost of the shares, and that would be the 15%. All right. So what happens in part during question 15? We're going to do just the opposite of what we did in my sheet, on my worksheet problem. We are going to issue stock and buy back debt. And I don't think that's a very common occurrence nowadays, since the cost of debt is so low. Why would you want to get rid of it? Okay, so first of all, we have to unlever the WACC. So I'll be tricky once again. I'll take my WACC calculation, I'll copy it. And if I want to do this all over again, what would I do? I'll paste it, I'll edit it, and I'll take out the 1 minus t, right? Just trying to give you a memory device. It's the same as the WACC without 1 minus t. And we get 12.35%. And that's what I got here. Okay, then we need the new RE. Okay, and the new RE, first of all, we have RU. We need the new RE. So we'll start with RU plus RU minus the new RD. In this case, RD is the same regardless. It's going to remain at 8%, times the new debt, which is the old debt minus 50, divided by the new equity, the old equity plus 50. And we're going to get 14.11%. I think I might have a question. Let me just see what I get here. Oh, that was just me. Whew. Why does it flash? I'm the one asking. Who knows? All right. So now we do the new WACC. All right, let's just do that again. We have, let me stretch it out. All right, so we have the new debt divided by the new value, which is the same as the old value, times the new RD, which is the same as the old RD, 1 minus t, plus the new equity, and that was what? 343.16 plus 50? Yeah, so 393.16 over the value times the new RE, and you should get 11.55%. Okay. Anything else here? Look good? Okay. Now let's go to 16. And 16 tries to be tricky. Okay, I don't know why this is flashing on me. Don't get it. 16 tries to be tricky. All right, it says in here. Debt will be repaid in 2 equal installments of $150,000 each. That sounds like rebalancing to maintain a constant debt to value. It is not. Okay, the appropriate cost of capital is 12%, with all equity financing. RU. Okay. And the part that's strange here. Assume debt tax shields have a net value of 30 cents per dollar of interest paid. So what they're kind of telling us here is that the effective tax rate for this company is 30%, isn't it? Okay, so let's take, first of all, the present value of the cash flows. And you know what? I didn't do everything here. I should have. And let's subtract the cost. There we go. All right. So I'll take the two cash flows, discount them at RU, and subtract the cost. I'll get 93.75. So one more time, is this a fundable project if it's financed all equity? Yes, it is. And then we will add, now we have repaying this back in 2 equal payments. So our first interest is 300 times 8%. Our second interest is 150 times 8%, gives me tax shields of 720, 360. Anyway, so we take the present value of these, oh, well, let me do it again. So equals NPV. What rate? What rate? Has to be, ooh, almost screwed that up, didn't I? 8%. Yeah, 8% debt. And what are our two tax shields? 720 and 360. Kind of like I put it in the financial calculator, isn't it? Do I need to write parentheses in Excel? I do not, because Excel will give it to me. And then I add the base case, present value tax shields. If you did it in thousands, this is what you get. So it's very much a fundable project, isn't it? All right, let's go to number 17. Okay, part A is similar to the rock crusher example in the book. It's perpetual cash flows, fixed amount of debt, 400,000. Okay, so let's do, first of all, the base case. So it's a negative million. I again, doing it in thousands. So negative 1,000 plus 95 divided by 10%. That's 950. So this one is not fundable if all equity financed, is it? First one we've had that actually fails the test. Not fundable with all equity financing. Okay, then we add the tax shields. And remember, we just came up with a new way to do this, didn't we? We said you could just take the debt times the cost of debt. Oh, sorry, times the tax rate, my fault. Times 35%. And you get the present value of the tax shields, won't you? Or it's the, that's what I did. Anyway, so the base case, add to that the tax shields, and we get an APV. So with the financing, it's something we can fund. Part B. Okay, first of all, we have to value this project. And we need RE. We don't have RE. And let's make sure we know we don't have RE. The opportunity cost of capital with all equity financing is 10%. Okay, so that's not RE, that's RU. So we find RE, we take the RU plus RU minus RD times the debt to value ratio. And in my lecture note document, I asked you to use 40% debt. Okay, and then plugging that into the WACC equation, I get a WACC of 9.02%. Okay, so then if I take the cash flow, divide by the WACC, I get the value. We'll take 40% of that and call it debt. And then we will take 7%, believe it or not, it's not 8 for once. 7%, that'll be the interest, the tax shield, times 35%. And so the present value of the tax shields, we're rebalancing, right? You gotta remember this. We're rebalancing, therefore I'm gonna use RU, aren't I, on the tax shields. Okay, and someone made the good point. Is the base case the same whether you rebalance or not? Yes, it is. So I simply went up and stole it from here. I have the base case. I add the present value of the tax shields. And I get an APV then of I got it right here, 5322. Okay, last one, float equity. I take the cash flow, subtract the interest, add back the interest tax shield. I discount this at my new cost of equity. And then the equity investment. Okay, remember that? Let's redo the equity investment, make sure we get it. Let's do it over here. Equals. Project cost was $1,000. And we borrowed against it what? Borrowed $421.29 against it. So the equity investment would be $578 against a value of $639. So there's an NPV to them. It's $53.22. So all three methods, same number. So I think we have all the questions. We're done. Yes, I agree. That was a heck of an assignment, wasn't it? That'd be right up there with the derivatives assignment, wouldn't it? About the same difficulty? No? Still easier in derivatives? Okay. I hate to say it, I agree wholeheartedly. You see, in your professional career, there's really two routes in finance. And one is if you're a real math head. And if you're a real math head, then you know stochastic calculus, you know all these processes, you get into all these mumble jumble models that use all these fancy math. The other one is the other route, that's me. I don't know stochastic calculus. I can take a Black-Scholes model and plug this in, plug that in, plug that in, plug that in, and get an answer. Do I have any idea what I did? No. In fact, I was at a different school at the time, and we interviewed a guy for a candidate. He was a candidate for a position, and he came from a school in which his mentor was the guru in the entire United States for derivatives. The absolute guru in the whole country for derivatives. So here's one of his prime students interviewing for a job at this school. So he puts up the Black-Scholes equation, and I said, okay, I have a row right here of students, and the first one says to me, what's that second term in the Black-Scholes equation mean? So I said, well, what does it mean? How can I explain that to an undergrad? That guy choked. He didn't know what to say. Well, that could be the bonds, that could be, you know. So do I feel badly that I can't explain it to undergrads? Not a bit. It's just not my area. Okay. Pedro, on the other hand, he lives and dies that stuff. And I go, salami, bologna, you keep it, you know. I worship at the altar of Pedro, you know, when it comes to that stuff. It's not me. All right, so now let's see, any last questions before we put this guy away? Any cells? Same question. Any cells I should show again? All right, I'm going to take that as a no. All right, and let's, what we'll be doing next is in just about every finance textbook, these textbooks, how do you sell more textbooks? You cover more material, right? More broadly covered material. So if I had this textbook, I could use it for a working capital class using the last few chapters. I can use it for an investments class using the middle chapters. So they have all kinds of things, but they don't do a thorough job except in some areas, and this one happens to be corporate. But they always have the others, and they have chapters 7 and 8, which is this book's version of portfolio management. Okay, and it hits it from a little different angle. All right, I used to have assignments for both chapters 7 and 8. I decided I don't need to do 8 anymore. That's the portfolio part of it. Okay, but let's go back to if I had a introductory course textbook, I could find a figure very similar to this, right? And so if we start with one average stock, just take the average of all the stocks and average all those standard deviations, and I'd get this number, say somewhere around 30%. And then I add a second stock. Now I have a portfolio, right? One stock is not a portfolio. One stock in 100 shares is not a portfolio. 2 stocks is a portfolio. You get portfolio effects. And the standard deviation continues to come down as I add stocks. And I'm randomly choosing this. Do you ever hear about that study? They have these people that, you get these portfolio managers, they make a lot of money. They work day and night, but they make a lot of money. I mean, a lot of money. And a bunch of students, I think it was at Harvard, basically took a cork board and spread out the stock prices in the Wall Street Journal. Then they threw darts. And whatever stock the dart hit, they picked it. And they created portfolios from darts. So how much skill did that take? None. Anyway, they found that that portfolio performed just as well as these managed ones where the people are making fortunes in most cases. Okay. So that's what's called market return. So how do we take advantage of our students that threw darts? We buy what's called an index fund, right? My wife has been doing this for years. She has the Vanguard S&P 500 fund. She buys that every month. Okay, now if you don't want to be as risky as the whole market, what do? Well, she combines it with some government bond funds. So part of her money's in the market portfolio, part of it's in the risk-free. So she's somewhere between, right? So that's just CAPM perfectly. She's doing it, all right? So here we're just adding stocks randomly. So how well could that dartboard have performed? Well, I think someone did this, and they took like 1,000 portfolios and tried it and averaged everything. So there's no sampling error. And it comes down to, it got somewhere between, say, I usually use 30 and 40%, that this curve is basically flat. And if I took this out to 1 million stocks, it wouldn't be much lower. It will never touch this line. So it's what the mathematicians call, it's asymptotically approaching this line, but never quite touches it, no matter how far out you go, right? So what we are going to do in chapter 7, that's this document, we are going to find a way to estimate this number. So in other words, what's the limit to diversification? How much risk can you remove by diversifying? What's the limit to that? Can you just continue to diversify and expect your portfolio risk to go to zero? You can't. And I asked the question, why? Well, you have market risk here, right? But why can't we get below this line? Well, if you took a portfolio course, you would see that the only way to drive this down to zero is to have a negative correlation between stocks. Okay, meaning this stock goes up, this one goes down. You can't find that. You generally find that if the stock market's up today, 60% or more of the stocks are up. If the stock market's down, 60, 70, 80% of them are down. They're just correlated. So you can't do that. So this is as low as you can go because of that positive correlation between stocks. Right? And we will have a little exercise where we are going to estimate this number. That's our ultimate goal, and we'll play with it a little bit, but I'm not going to hack into that today and get anything done in 5 minutes. That's worthwhile doing. So let's just cut it off. And we'll start with chapter 7 on Thursday. We have a whole day to do it. I'll do it. All right. Okay, well, I'm going to say goodbye.